Hi guys, this is step 4 of the hands-on train and deploy real-time ML tutorial. Today I'm going to show you 3 tricks to train machine learning models. Let's go to the code. I'm going to open the train.py function and then I'm going to scroll down so you see the entry point of this script. Here I'm specifying the input parameters to the script. This is the first trick. So when you train machine learning models, you often start with a set of parameters, for example, what type of model, what type of data split, and so on, but you start iterating. So you want to try lots of stuff. The best way to do that is to add the most important parameters as inputs to your Python script. And the most straightforward way to do it is using the argparse library from Python. In this case, I have four parameters, which are the name of the model. In this case, Lasso is the default value. This is a linear model with a little bit of generalization. Then whether or not to tune hyperparameters, this is a Boolean. Sample size, so the larger the sample, the better the model, but also the longer you will need to train. So it's good to start with small sample size so you can iterate fast. And then when you're comfortable with the model, then train it full on the entire data set. And then the number of hyperparameter trials. So this is the first trick. Specify the most input parameters of your whole script as input parameters to the Python script. Then let me go to the main function, the train function. Here, as usual, we start an experiment. So we'll want to log everything using CometML. And then we split the data. We use the same split as we use for the baseline model. And then, depending whether we tune hyperparameters or not, we create our model slightly differently. I'm going to show you the most complex scenario, which, well, we tune hyperparameters. How does this thing look like? First, you need to find the best hyperparameters, and you use that using cross-validation. I'm not going to go into the details. You can check the code, but basically, with this first step, we find the optimal hyperparameters. Once we have them, which are the optimal hyperparameters for pre-processing and for the model itself, we use them to create our pipeline. This is the second trick that I want to show you. These are scikit-learn pipelines. This is a very convenient way to package pre-processing and modeling steps into a single object that you can later serialize, that you can save to disk and reuse it as it is. This is very convenient when you want to deploy the model later on, to have the pre-processing and the modeling steps compressed into a single object. Then, once you have created the model, which I call pipeline, you fit it. This is when you train it, you find the parameters. And then we use the train model to compute testing errors. So we compute the mean absolute error, and as usual, we log it to our CometML. Then finally, this is the third trick. When you train models, it's good not only to log the metrics, but also the model artifact itself. This is what we do in this final line. So when you log the model and you push it to the experiment tracker, to CometML, it's going to be easier later on to deploy it. Why? Because models do not go straight from your local computer to the REST API endpoint, but they go through what is called the model registry. This is something that we will see in the next block, but it's really important to emphasize. So when you train models, log metrics and also model artifacts. So if you want to run the model, it's enough to just run, for example, Python source train, and then for the model, I'm going to try Lasso. Super training completed. I'm now going to go to my dashboard on CometML, and here it is, the experiment. So I added the tag Lasso to identify the model, and also, well, I still do not see the metric error. It's still running, so I'm just going to wait a little bit. And here it is. So I also got the mean absolute error. As you can see, the test metric of this model is actually a little bit higher than our baseline. So this is to say that the baseline model that we created is actually really, really hard to beat, at least with the input features that we are using in this tutorial. So that's it for this lecture. Let's move on to the deployment part.